So, when you're reading something really complex, like a technical document or even just some really dense piece of software,
Hmm.
and you get that immediate overwhelming feeling of just, I don't know, clutter.
Yes.
The core purpose, the main action, it just gets lost in all the definitions and the setup. It's like opening a map and finding 100 footnotes spread across the page.
It's a universal challenge, really, but it gets magnified in programming, especially in functional languages where structure is just paramount.
Right.
Clarity doesn't just make code readable, it fundamentally changes how maintainable that code is. If you mix the setup logic with the execution sequence, a reader's cognitive load just doubles.
Because you're trying to figure out two things at once.
Exactly. You have to parse what something is while simultaneously tracking what that something does.
And that is precisely the problem we're diving into today. Our source material comes from the canmeng.org blog, from the notes of a writer named Ang, who describes himself as an old software plumber.
I love that description.
Me too. It's about dealing with the real-world grit of building systems. And this deep dive focuses on finding the single most effective way to structure Haskell code.
We're looking at, really, the grammatical heart of Haskell here. How to correctly balance the do block, which is for execution, against the where clause, which is for definitions.
And what's our mission here?
Our mission is to understand the most, let's say, idiomatic approach, the one that makes the what is being done, the main action perfectly distinct from the how variables are being defined, the setup logic.
Okay, let's unpack this. So Ang explains that his first instinct, like a lot of programmers, when faced with dense code, was to break it down.
Into smaller, digestible pieces. Makes sense.
And the tool he reached for to manage these intermediate steps was the let binding. But he put it inside the do block.
Which is a very natural starting point. I mean, when you write a function, you often think chronologically.
Step 1, Step 2, Step 3.
Right. Step 1, define variable A. Step 2, define variable B. Step 3, execute the main action using B. And in Haskell, you do that with let bindings right after your function starts.
So if we look at the source's first example, it's a function for setting up command line options. The structure is clear, but it's still, visually cluttered.
It is. The function starts with main do, and boom, you immediately hit the setup.
You're reading the setup logic right in the flow of the function itself.
That's it. The do block is designed for sequencing actions, and yet the first thing it does here is define 3 variables using let.
The parser, modifier, and ops variables.
Exactly. And those are all definitions for how the program will handle command line inputs. You see ops being defined as info parser modifier. That's pure setup.
And only after those 3 lines of setup does the code finally get to the single line of actual execution. X parser ops.
And the problem isn't that this code doesn't work. It works fine. The issue is purely cognitive. For someone reading this function for the first time, they have to stop, register 3 lines of definitions before they even know the function's ultimate goal. It forces you to sift through all this logic that's tangled up in the execution sequence.
It's like reading a novel where the main character's tragic backstory is just dumped in the middle of a huge fight scene.
Yes, you just want the action.
And this is where the author, our old software plumber, discovers a genuinely better tool for this.
Enter the where clause. It offers a powerful structural alternative that, it fundamentally changes the reading experience. The key is that where moves those local definitions entirely outside the main execution flow.
Yeah, I can immediately see the appeal just in terms of visual cleanliness. Looking at the second example he provides, the function signature main.io is immediately followed by one line that tells the whole story. Main XX parser ops.
So clean.
It's incredibly clean.
Instantly graspable. The function's purpose is laid bare. The goal is to execute the parser options. The reader doesn't need to know how ops was built unless they choose to look down at the footnotes.
But wait a minute. Let me play devil's advocate here. If I put all the definitions, parser, modifier, ops at the bottom under the where clause, doesn't that just make me scroll down to understand the variables? Isn't that a readability sacrifice?
That is a critical question, and it really speaks to the philosophical difference between imperative and functional programming. You're asking, why sacrifice chronological reading for structural separation?
Yeah.
The answer is purity.
Purity. Okay, explain that.
Well, everything in that where the definitions for parser, modifier, ops, it's pure declarative setup. It's static. It defines what those variables are.
Okay.
They're constant definitions that don't depend on sequence or state changes. The compiler knows this, and so the reader should too, by moving them to where we're declaring that this is the pure immutable setup logic.
So it's not just about tidiness. It's a functional guarantee. The do block is for sequential actions, things that have to happen in order. The where clause is for pure setup things that just are.
Precisely. We're enforcing a separation of concerns based on functional purity.
Yep.
The where clause acts like the list of ingredients at the top of a recipe. It's the reference material.
And the function body is now just the one command.
Execute the main dish. It dramatically simplifies the function body, focusing it purely on the high-level action.
And I appreciate the detail the source gives us here, especially for you if you care about coding best practices. The author notes that even the standard Haskell formatting tool, Formaloo, it enforces this.
Right. It typically formats these where clauses with a standard two-space indentation.
It's a huge tell.
It's crucial. When the professional tooling enforces a certain look, it confirms that moving definitions to where is the established idiomatic way to do this in Haskell. It's not just a preference, it's a standard.
That brings us to the ultimate synthesis then. We've established where is the best place for pure definitions. But Haskell functions often involve sequencing actions that need to, pull results or interact with the world.
Right, and that's where we need both tools working together.
Okay.
This combined structure isn't just a style choice. It's a necessity when you need to handle what the author calls monadic results.
Monadic results. Okay, that's one of those phrases that can send new functional programmers running.
It can be, but the source gives us a really accessible conceptual definition.
Good.
And we should stick to that level. The author describes a monad simply as a value within a context or container.
A container.
Yeah. This context might involve sequencing, state changes, error handling, input-output. For our purposes, we just need to know that these actions produce results that have to be handled in context. They aren't just pure static calculations.
Okay, so if the action involves a context, like getting data from a file or parsing an argument, we need the do block. We can't just define those results in a static where clause.
Correct. The do block becomes absolutely essential for these sequenced, contextualized steps. This is where you see that famous Haskell arrow.
Right.
It signals that we are running an action and pulling a result out of that context.
Let's look at the third example then, the true best practice synthesis. Now the do block actually holds an action we see. Result, exec parser ops.
That line is the heart of the action. We're executing the parser and getting a sequenced contextual result, which we bind to result. This must happen inside the do block because it's an execution step. It depends on order.
And where are parser and ops defined, the setup variables for this action?
They're completely isolated in the where clause, exactly as before. The where clause still holds those pure static definitions. This final structure perfectly separates the two concerns.
So the do block is now purely for execution sequencing, the imperative part.
And the where clause is purely for definitions, the declarative part.
So we have a really clear dividing line. If a variable definition is pure, a constant, the simple function, it belongs in where. If the code is executing an action that has to happen in order, maybe pulling a result from a context with that arrow, it belongs in do.
That's the core takeaway. This isn't just a style guide. It's a philosophical commitment to clarity. When you use where for definitions, you guarantee those are stable, pure bindings.
Right.
And when you use do for actions, you guarantee that you're tracking the sequential steps. It makes debugging so much simpler because you immediately know which part of the code is the static setup and which part is the dynamic execution.
For you, the listener, the key lesson here is clarity through that intentional separation. That structural split is the real nugget of knowledge.
It is.
In Haskell, you use the do block for imperative sequencing, the actual ordered steps, and the where clause for pure declarative definitions, the setup variables.
And what I love about the source material is how universal this principle is. This author, Eng, isn't just writing about Haskell, he's also writing about Python, Rust, Elixir, and even gardening and fishkeeping. Yeah. It just underscores that mastering structural thinking, knowing where to put your definitions versus your actions, is the key skill, no matter what you're doing.
Absolutely. The discipline of separating setup from action, it transcends programming. So we established that combining do and where is essential when you're handling those monadic results, values, in a context.
Right.
And if we need this strict structural separation just for simple argument parsing, Consider how exponentially crucial this split becomes when the actions themselves involve really complex states.
Like coordinating multiple database transactions, or handling file I/O, or managing intricate error logs.
Exactly, which raises an important question. We focused on Haskell, but what other programming languages or, I don't know, even structured writing disciplines like legal briefs or engineering specs could benefit from such a strict split between definition and action?
That's the provocative thought, isn't it? What are your functional where clauses? Something to mull over as you organize your next complex project.
That's all for this deep dive. We'll see you next time.